Well, if the front end is the stage, right, the scenes in a play, then the back end would be backstage. All the ugly stuff, right, that goes on, the not so pretty, right? There's people changing in the back, people in a rush, uh, people trying to be on time and stuff. Well, same with the back end. The back end is all the calculations, the uh, transforming inputs into outputs, all the difficult stuff. Sometimes people say backend is harder than front end. Others might argue with that. But yeah, backend is all about the logic of the app, handling the data, the processing of that data into useful output, and security as well. So we'll talk about APIs and services later on. But just know backend is all about the brain of the app, right? Making sure that it actually functions correctly. So if the front end is like a shell for the data, the backend is the calculator for that data, making sure that those inputs are transformed into the right outputs. So there's a lot of different roles in backend. There's software engineers, backend developers, software architects. Cybersecurity is not considered part of backend, but it is tightly integrated with it. So they do work alongside with the backend quite a bit. That cybersecurity team. Cybersecurity, one of the hot roles these days, right? Because as we learned with the internet, right, people are always after our data. We're always under attack. So the metaphor, right, I've been using the front end is the stage, the scenes, the back end, right, is all the logic that's going on behind the scenes. Not as pretty. If you look at back end code, it's definitely can be a little bit crazier than the front end. Again, some people might argue both are difficult in their own ways. I do have to say, back end does require a very logical, mathematical mind, whereas front end is a little bit more on the creative side. So part of the backend is typically a database, right? So if we're handling millions of records, you're going to need a specialized software called databases. So all they do is store, retrieve, and manage information. So every time you're, logging in with your username and password, it's actually comparing your username and password up against to a database to see, hey, does this username exist, and does this password match up to what it should be? It's definitely more complicated than that, right? There's hashing and cryptography involved, but we're not going to get into that. So there are two main types of databases for storing these millions and billions of records. There's relational databases and non-relational. Relational databases we call SQL. That's the language we actually use to interact with those databases. And then we have NoSQL, which pretty much means not SQL. So what's special about SQL and NoSQL? SQL uses tables to organize data. If you remember from spreadsheets, uh, a SQL database table looks exactly like a spreadsheet. NoSQL will use many different formats. There's not one format for NoSQL. It pretty much just means it doesn't use a table. So they're going to store information. These databases doesn't matter if it's SQL or NoSQL. Both will just store information like the user accounts, transactions, product details, usernames and passwords, location data, for example. Anything that you want to store on the user and retrieve for them to show them at a later time, a database will handle that. They're very, very efficient at searching, updating, and scaling data. So even if you're dealing with billions of records, it can still retrieve that information in, less than a second. Very low latency. So they're typically hosted on servers. We'll talk about that a little bit more in the following slides. But some of the roles related to databases are database administrators, architects, and data analysts. Those are people who are trying to analyze, right, the data inside of a database. So like I said, very similar to Excel, to spreadsheet software. It's just a table, rows and columns. So if you look at the Facebook users, and there's a database on them, you're going to see just a bunch of rows because there's billions of rows, billions of users, and then many, many different columns, right? I'm sure Facebook is tracking so many different sets of data for the user, including their name, their location, right, username and password, etc. And always, 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 because people can have the same first name, the same last name, we typically have a unique ID for all database records. So those unique IDs make sure that, hey, we're not confusing one user with another. So even if there's two John Does, one John Doe might have ID of one, The other John Doe might have ID of I don't know 502, depending on where they land on the table. This is a big one. Application programming interfaces, huge for backend. When I first started building applications, I actually didn't use APIs. I was a bit intimidated by them. I felt like I didn't understand how they worked. Later on, when I had my first internship, I had to use an API because now I was building an app that would work with maps. In fact, I was building an app that would help refugees get to safety. They would have to find a certain handler, is what they call them, a certain person that would handle their processing out of a country or out of a danger area, danger zone. So that would involve GPS information, right? Map information for the user to guide them to the right place. Also had to handle storing these records, right, in ways that the handlers could process and make sure, right, that everybody who needs to be evacuated was evacuated correctly. It turns out I didn't have to build those systems from scratch. I didn't have to build, a maps app from scratch, which is what I thought initially. And it terrified me. I was like, I definitely cannot build map software right in the next couple months. So fortunately, there's application programming interfaces, which are like the Legos of building apps. So a lot of the different functions and features that you want for your app, they're pre-built. They're already out there ready for you to plug in, to stack together, right, to build your own app. So maybe you need map data, maybe you need weather data. There's an API out there ready for you to plug into your own app. So they're commonly used in apps to connect front end and back end. They also help you interface with databases. But again, they also let you take advantage of really cool features. So any feature you want, there's probably an API out there to help execute it for you. You could certainly build it from scratch, but reinventing the wheel right doesn't always go well. It's better to use something that's tried and true, something that's been tested over time, versus building something brand new, right? And like I said, when you're building software, a lot of times you're introducing lots of bugs, right? That's just part of the process. So yeah, APIs help developers build systems faster. So again, you don't have to build everything from scratch. You don't have to, in the example of a chef, right? You don't have to build, you don't have to cook everything from one ingredient at a time. You can go to the store and buy some of these. And in the case of APIs, some of these are even free. So if you need map data to locate the user or give them certain addresses, you can use Google Maps API. If you need to handle payments, you can use PayPal or Stripe. Weather APIs like Open Weather Map is an example of weather APIs. So all this information, rather than you trying to build it your own, you can definitely just plug it into your existing app. Now, some of these APIs, like Google Maps APIs, do charge after a certain level of requests. That's where you can pass on those costs to the user, right? So this is what it might look like building a modern app. You're putting a lot of different Lego pieces together, right? We have our social media API, payment API. Something that terrified me was handling login information. I didn't really understand it. Turns out there's an API to handle that as well. So I don't have to worry about securing users' data. I can use an API for that. Database APIs, since that's technically another software, there is an API to interact with it. Weather APIs, map APIs, etc. There's so many APIs out there, and what this means for you as a solo developer or young developer that's learning how to build apps, you can actually build some really cool apps very very quickly, and you don't have to fully understand how these interfaces work, right? You just have to understand how to plug it into your own app.